Hi guys! Getting into chapter 9 now, which is still statistics and data. In 9.1 in your textbook, you see this chart that represents years starting in 1998 and moving forward 1 year at a time till 2004, and then percent of total sales from music stores. Okay, that means like an actual store you walk into to purchase music, which I know in your generation may seem strange to you because you probably buy most of your music off of something like iTunes or something like that, and you don't really go into a store like FYE or Best Buy or something like that to buy much music anymore because there's so many other options. But back in 1998, since I was alive at that time, I can tell you that there were not such things as MP3 players and iPods and so forth, and that was not an option. If you wanted music, you had to go to an actual store to buy it. And we can see that starting in 1998, 50% of all music sale was from a music store. If you didn't buy it from a music store, you bought your music from someplace like Walmart or Target, or something like that. But with the advent of MP3 players and iTunes and buying things off of Amazon, going to an actual store to buy music is kind of is declining, as you can see through these numbers. Okay, so what you're going to do first is go into your calculator and stat edit. Okay, and I have some values in there that you can ignore right now, but in your L1, remember, we don't put years in, all right? This is going to be 0, 1, 2, 3, 4, 5, and 6. We're going to put those values into the L1, and we'll put these values into L2. So once you do that, and while you're doing that, you're also going to plot these values on this scatter plot. And poof, there's the scatter plot done. Okay. It says use your calculator, but we're not going to do that right this minute. Okay. Describe any patterns you see in the data. Well, I see that this data appears to be linear. Well, let's linear and decreasing. Okay, which we expected it to be decreasing by looking at the data, but it's also linear. Then the next thing, number 4, is you've got everything in your L1 and your L2. It wants you to write a linear regression, round the values to the nearest hundredth. Whoa, I didn't mean to do that. Okay, so the nearest hundredth. So f of x, or y equals, doesn't matter, negative 2.97x plus 48.89 for the nearest hundredth. Okay, now the directions specifically said nearest hundredth. If I didn't have directions telling me how to round, I would follow the data, which was nearest tenth. But we're going to follow directions. Okay, so this equation represents the data if it had fallen more smoothly in a line. All right, let's interpret the equation in terms of the problem situation. So let's write down our rate of change and our y-intercept. So negative 2.97, in very generic terms, it's our rate of change, but if we're going to be specific, it is the percent decrease each year. Okay, 4889 is the y-intercept, but more specifically, it is the percent that we started with. Now, I just want to re-emphasize the difference between the rate of change we get by doing a regression and the y-intercept we get with the regression, comparing that to actual data. Okay, so if we can't hang back here, we look at this data. Okay, the very first data point is 50.8, and we can see that y-intercept right here as 50.8. Okay, however, 48.89 is what the calculator said the y-intercept is. Keep in mind, one more time, guys, that the line that represents the data is not the data. It's close. It's what we use when we want to make predictions or to see how good our data is. Okay? Okay. So I need to also talk about something called interpolation. Okay, interpolation is where we are using our regression equation to make predictions, and the key word here is within the data set. In other words, we have data, but let's say I wanted to predict what the equation would tell us and compare it to what actually happened. So here's our data entered into L1 and L2. I'm going to show you how we can look at the stat plot. In other words, we made our own copy by hand of the scatter plot, but you can also do it on the calculator. Okay, the default is your stat plots are off. So second stat plot will bring up this menu. See how they all say off. Go and click enter for stat plot 1. And right now it's set to off. We want to hit enter and set it to on. The type of graph right here is dots. That's what we want. And then we want zoom stat. That will automatically make the window the right size. And we see these dots, which look pretty similar to this graph right here. And that's kind of the idea. All right, they're the same. Now, if I go into my y equals, and put in our equation, negative 2.97x plus 48.89, and hit graph, I can see the line of best fit going through the data. Okay, so that illustrates the difference between the equation, which is not the data, and the data points that are actually the data. And sometimes the equation and the data is right on. For example, this dot right here, right on. Sometimes they're kind of further off. Okay, so interpolation is where I would be using the equation to make a prediction and seeing how close it is to the data point. Or interpolation could be if I asked about halfway through the year 2000. So here's 1998, here's 1999, here's 2000, halfway to 2001. There's no data point there, but I could put in 2.5 for my equation and I could interpolate what I predict the music sales would be from a store. Okay? Okay, so it says use your equation to predict the percent of total music sales that came from music stores in the year 2000. Well, remember, the year 2000 is year 2 in our data. So we would be subbing in into our equation. So f of 2 equals negative 2.97 times 2 plus 48.89 48.89. Now, you can sub it in, do it on the calculator, but don't forget that your calculator will do this for you. It's not being a pain, okay? Go to your, once you have your equation in your y equals, you can go to your table, and year 2 would be 42.95. Or you could just type all this into the calculation window and get the same thing. Okay? Now compare the predicted percent. This is predicted. Okay, that's what equations do, is help us predict, to the actual percent in 2000. Well, the actual 2000% was 42.4. .4. Okay, so this is the actual. So if we're going to predict them, if we're going to compare them, I could say that they're not equal, but the two values are very close. Okay. Then, let's move forward and talk about extrapolation. Extrapolation is when we're going to use that equation and we don't have anything to compare it to. So this is asking about the year 2010. Well, if we go back, we got to figure out what number that would be. So 2004 would be 6. Okay, so 6 more than that would be 10. 6 plus 6 is 12. So that would be 12 years in. Come on. Okay, so f of 12 is negative 2.97 times, oops, I forgot the 12, times 12 plus 48.89. And you can type all that into your calculator, but if you have the y equals already in there, you can also find it in your table. Okay, there's the 12, 13.25. Okay, so 13.25% of music is being bought in a store as opposed to like an online source or something like that. Okay, that's extrapolation. We don't have any data to compare it to because it's outside of the data we collected. Okay, you could also go like 1900. Well, 1900 would be before we even started. So if 1998 is year 0, then 1900 would be like year negative 97 or something like that. And it's not that you can't have negative years. Negative years would simply mean prior to the data being collected. Okay, but in the year 1900, people were not buying music yet. Music as a record or anything like that, don't quote me on this, but if it was invented at that time, only the extremely super wealthy would have something like that. Okay, I don't know when music players and records and things were invented, but it was certainly 1900 is pretty close. Okay, and you might get too large of a value. Here, in fact, is the work from the answer key. So 1900 would be 98, negative 98. Okay, and so subbing that in, negative 98 just means 98 years before the data started, and we get a value of 339.95. Well, remember these are percents. And this is an instance where we cannot have a percent greater than 100. We can't buy more music than all of the music. Okay, if we're talking about 100% represents all the music is bought in a store, then you can't have more than all of it. So that would not be reasonable to have a percent that high. Okay. On the flip side, you're going to have to use some common sense answering some homework questions, because it's going to ask you if something sounds reasonable. Okay? And something you have to, like I said, use some common sense. Common sense tells me I can't have a percent, in this case, higher than 100. You might be looking at common sense telling you that you can't have negative of something if you got something that turned out negative. You might have common sense telling you that, this is not reflective of a homework question, but just in general, what if something, your predicted value was in the trillions of people? Well, there aren't trillions of people on our planet. There's only about 7 billion people on the planet. So if you extrapolated far beyond what makes sense, that means that, an equation that's predicting something may not last forever, may not predict something to infinity. So be careful of that. That's a common sense thing on your homework. All right. Now, speaking of homework, goodness gracious. Okay? This is an awful lot of work. Okay? Something called least squares regression. And it is no different than doing a calculator linear regression. In fact, this is what your calculator is doing when we are having it do a linear regression. These are all the calculations it does. Okay? And that looks nauseating, frankly. Okay? And we're not doing that. So what I want to show you is that we're going to use our calculator to do this for us. But when we're given things in coordinate pair form, remember that 3, 7, and -2 are x values, and they go in your L1. 4, 6, and -4 are y values, and they go in your L2. So make sure you're putting them in your calculator correctly. Okay? Then stat, calc, linear regression. Okay? And you'll notice that they get the same A as your calculator, they get the same B as your calculator, and we can write the same darn equation using the calculator and not have to do all of this by hand. You are never going to be asked to do that by hand on your regents. We're not doing them by hand. Okay, so don't worry about that. What I do want you to do for your homework is write down the A, write down the B, and write your linear regression equation. Okay, that's all you need to do. You have a lot of space that you're not going to need to do that in. Okay, so that's your 1 through 6. You're doing that all on your calculator. You're not doing any of that like this by hand. No, no, no. Okay, when it comes to 7 through 12, don't forget that the L1 actually starts with 0. So for 2008, that means your x value is 2. You're subbing in a 2. Okay, 2008 is a value we're given in the chart. That's interpolation. Let me find one that's extrapolation. 2014, number 10. That is not in our chart. That's off the charts. So there we're not going to have a value that it actually came out as. For 14, we can't compare it to what the actual data is to see if it's reasonable or not. We're going to use common sense. Okay, now, if you've ever taken a test and the answer has been C for too many times in a row, you start to get nervous and question yourself and think you did something wrong. I'm going to give you the fact that for 7 through 12, all of your answers are reasonable except one. And the one that's not reasonable is super obvious. So don't worry about that. They're all reasonable except for one, and that's a super obvious one. Okay? All right. Have a great day. See you next time.